All right, so linear equations and applications of linear equations. So linear equations are equations of lines. I remember that because in the word linear, there is the word line. So that's why it's called linear, because they're lines. So anytime you have a linear equation, you're thinking of a line. Average rate of change is just a fancy way of asking for slope. And let's remind ourselves that slope is rise over run, or change in y over change in x, where that triangle is the Greek letter delta, and delta is the mathematical symbol for change. You could also say that it is y2 minus y1 over x2 minus x1, keeping in mind that slope is commutative in that the order that you put the points in doesn't matter. So the slope from A to B would be the same as the slope from B to A. So that's my gangbuster super quick review of slope. So to find the slope of a line, I would pick any two lattice points. And by lattice points, I mean points that cross at integers. So like this right here looks like a really good lattice point, and this right here looks like a really good lattice point. I wouldn't consider this a lattice point because it doesn't go through like on a lattice point. So to find the slope now between those 2 points, we are going to just count the rise over the run. So we're going to go, how far up does this go? And then how far over does it go? So this goes up 1, 2, 3, 4, 5. We're just counting boxes, and over 1, 2, 3, 4. So that makes the slope, remember m is the letter that we use for slope, 5 over 4. And so since average rate of change is just a fancy way of asking for slope, the average rate of change is 5 over 4. So then we're going to do the same thing for the next question, only they've given us 2 points. So I'm going to use this equation for slope. I'm going to label them x1, y1, x2, y2. And then I'm going to find the slope. So the slope is -1 minus -7 over 2 minus -6. -1 minus -7, that's going to become +7. So -1 plus 7 is 6. 2 minus a -6, remember minus a negative becomes plus, so that becomes 8. And then 6 over 8 reduces to 3 over 4. So that's slope, or average rate of change. Now, to determine whether or not something is a function, you need to have a constant rate of change. So your ratio of rise to run has to be the same throughout the entire table. So in order to determine that, what you're going to do is you're going to find the differences of each set of points they give you. 5 minus 0 is 5. 10 minus 5 is 5. 10 minus 15 is 5. -1 minus 9 is -10. -11 minus a -1, -10. -21 minus a -11, -10. And then you're going to check 5 over -10, 5 over -10, 5 over -10. That's this 5 over -10, this 5 over -10, this 5 over -10. If all of your fractions are equivalent, not equal, but equivalent, meaning they would reduce to the same thing, then yes, it is linear. So I'm going to say that that one is linear. And what do I mean by that? Well, if I had 1 over -2 somewhere, it would still be linear because this reduces to this. or excuse me, this reduces to this. Okay, so let's try it again. 5 minus 0 is 5, 10 minus 5, 15 minus 10. 10 minus a negative 5 is 15. 20 minus 25, excuse me, minus 10 is 15. 40 minus 25 is 15. And again, this would be, ooh, I did it backwards over here. It should be y over x. 15 over 5, 15 over 5, 15 over 5. Since those are all the same, this one is also linear. Okay, so here we have 10 minus 5 is 5, 20 minus 10 is 10, 25 minus 20 is 5. 31 minus 16 is 15. 61 minus 31 is 30. 76 minus 61 is 15. And then we set up our ratios. 15 over 5, 30 over 10, 15 over 5. Hi! Oh, sorry. Baby, please don't close the door. See how even though these fractions are not the exact same, they all reduce to the same thing? That means it is linear. Okay, so that's what I mean by the fractions are equivalent and not equal. It did work out that in these first two examples, our fractions were equal, but in this third one, the fractions were equivalent. So it was a linear function. Okay, so then 5 minus 0 is 5, 10 minus, okay, over here. 34 minus 9 is 25. 109 minus 34, I'm not confident in doing that. There you go, 75. 234 minus 109 is 125. So I would have 25 over 5, 75 over 5, 125 over 5, which would then be 5, 15, and 25. See how when reduced, these three fractions give me, these three ratios are completely different. So that means this one is not linear. She's been doing this thing lately where she likes to shut doors and then she likes for you to knock and then for you to open them so that she can be like, hi! And then she'll go, bye, and shut the door again. So she's outside the door right now knocking. Gotta love that life with a toddler. I hope you guys can't hear the conversation going on outside my door right now. All right. So to find the equation of a graph of a linear function, we need two things. We need the slope and the y-intercept. Remember, the equation of a linear function is y equals mx plus b, where m is the slope and b is the y-intercept. And that is slope-intercept form. Slope-intercept form is y equals mx plus b. So our y-intercept is right here at 1. So my b value is 1. And then to find my slope, I'm again going to find two lattice points, any two lattice points. So I'll use the intercept because I've got it. And then how about this one right here? And we're going to do the same thing we did before, where we're going to count. Now keep in mind that if your rise is negative, then your slope is negative. So we're going to count down 1, 2, 3, 4, 5. So my rise is negative 5 because it doesn't rise, it actually falls. And then over 2. So my slope is negative 5 over 2. So then y equals negative 5 over 2x plus 1. If your slope falls, if your line falls, then your slope is negative. If your line rises, then your slope is positive. So y equals negative 5 halves x plus 1. And then for this last one on 2.1, given a table, we're going to do essentially the same thing. Let's find the slope first. So we're going to use our y2 minus y1 over x2 minus x1. And I'm going to say this is x1, this is x2, this is y1, this is y2. So my slope is negative 126 minus negative 36 over 30 minus 10. In the top, negative 126 minus negative 36 becomes negative 126 plus 36. That's going to be 90. Negative 90. And in the bottom, 30 minus 10 is 20. Negative 90 divided by negative 20 is 4.5. Right, because the zeros would cancel, and 9 divided by 2 is 4.5. Or you could just leave it negative 9 halves. Whatevs. So now we have y equals, excuse me, negative 4.5x plus b. Right, because we had y equals mx plus b. And we figured out that m was negative 4.5, so I plugged that in. Now I'm going to take any point, and I'm going to plug it in for y and x. So let's use the first point. Y is negative 36 equals, not plus, no, negative 4.5 times 10 plus b. Then negative 36 equals negative 45 plus b. Add the 45. B is 9. So then y equals negative 4.5x plus 9. Now, a hint to you that it is never a bad idea to double check your work, especially because if we're thinking about the fact that you have a test coming up, on that test, you're only allowed one answer. Like you can only enter each answer once. So there is no 3 and then try another similar. You put in one answer, you press enter, and that's that. So for me, if this were my test and I knew that I only had one shot at this, I would put this in my calculator. And then I would go to my table and I would enter these numbers in. 10, 30, 40, 50. Did I get the same values in my calculator that I have in the table up here? Yes, I did. So I'm 100% sure now that this is the right answer. So before I hit that submit button, I can feel confident knowing that that my answers were right. There we go. Are you with me on that one? Okay, so y equals negative 4.5x plus 9. You could do the same thing up here with this one, where you could plug this in and say y equals negative 5 halves x. Damn it. Negative 5 halves x plus 1. And then graph it this time because they gave us a graph. So this time, instead of looking at the table, I'm going to look at the graph and I'm going to compare. Oh, that's right. My settings are all messed up. As a side note, if your window is weird, if you press the zoom button and then choose option 6, you see right here, standard, that's going to get you back to your regular standard viewing window. But then you can compare this line to the line on the paper and say, oh yeah, those look the same. So I'm confident now that that was the right equation. Okay. So especially on your unit test where you only have one submission per question, if you have questions like this that you can easily verify that your answer was right in the calculator, I would do it. I mean, it's your grade. Nobody's forcing you to, right? I'm not going to be standing behind you going, did you check that in your calculator? But if it was me and it was my grade, I would check it. Anyway. Okay, so then next was 2.2.
Hey, Jess?
Yeah.
I had 3 pages for my 1.2 notes.
Oh, did you? So then was that this?
Yep.
Oh, okay. I thought this was part of 2.2.
Okay.
Sorry. Duh. Okay, so keeping in mind that my slope intercept form is y equals mx plus b, where m is my slope and b is my y-intercept, like I said. Remember that slope and average rate of change are the same thing. So they ask you for average rate of change, you're just going to pick the number attached to the variable. And g of w is the same as y, so my y-intercept here is 82. Please don't overthink that one.
They like it in intercept form, so it would be parentheses 0, 82 parentheses.
Yeah, that makes sense. They want it as a point since they're asking you for an intercept. Okay. Thank you for letting us know, Katie, since you already, sounds like you already started that. Okay. So, a couple of short word problems. It says a phone company charges for service according to the formula C of n equals 21 plus 0.05 n, where n is the number of minutes and C of n is the monthly charge. So we've talked about slope being the rate of change. So that means it is the change in y over the change in x. So here what we're saying is that my slope is the change in the monthly charge over the change in minutes. Another way to say that is that it is my dollars, because monthly charge is in dollars, right? Per minute. And so the rate of change is just that number attached to the variable, 0.05. And then your select an answer is going to be dollars per minute. So your rate of change is always y per x. Okay? Rate of change is always y per x. And your initial value is always just a y. So my initial charge is 21, and that's going to be dollars. So your drop down here is going to be dollars per minute, and your drop down here is going to be just dollars. This drop down is going to be y per x, and this drop down is going to be just y. Okay. This print is super small. Town's population, P of X, has been growing linearly. In 2003, the population was 37,000. 1,200 people per year. Look, it even uses that language. People each year, just like I said up here. Y per X. Write an equation for the population as a function of X. After 2003. So then what that means is that 2003 is my initial year. So that is when that is your intercept then. So the equation for this would be y equals, or in this case, it's P of X equals your rate of change, which is 1,200 people per year, plus your initial value. And since they started taking the census in 2003, that 37,000 is my initial value. So that's what would go in that very tiny box right there. So again, keeping in mind that this is y per x, the population will reach, let me see what number that is. Is that 23 or 33,100? Nope, that can't be. Oh man, my contacts are getting fuzzy.
Looks like 88,100.
88,100, you're right. So then the population will be 88,100. Population is people, that's a y value. So that means that they want to know when y is 8,100, what is x? So I'm going to plug in 8,100 for y, or 88,100, and I'm going to solve for x. Subtract the 3,700 from both sides. 37,000, 1,000. I missed a 0. So 88,100 minus 37,000. I didn't miss a 0 on that, right? It's 1,200, not 12,000. Divide both sides by 1,200. And so then that means it'll take 42.5 years for the population to reach 88,100. If we started in 2003, then that means it would happen in the year 2045. It'll be about halfway through that year that it happens. For a question like this, they don't usually want you to round because it's going to be during the year 2045. That's the way I would do it anyway. More might ask you to round, so they might want 2046, but I doubt it. And then the last one says the population in the year 2009. So 2009 means that we're 6 years in. So that means that my x value here is 6. So then y equals 1,200 times 6 plus 37,000. I'm just going to do that in my calculator in one thing. 1,200 times 6 plus 37,000. So in 2009, there will be 44,200 people. Okay. All right. Ooh. A clothing business finds that there is a linear relationship between the number of shirts it can sell and the price it can charge. In particular, historical data has shown that 6,000 shirts can be sold at a profit of $40, while 8,000 shirts can be sold at a profit of $28. Write the price in P as a function of the number of shirts sold. So the price in P then is my Y, and the number of shirts sold, it's a function of X. It's Y is a function of X. So here P is a function of S. Right? Shirts sold N. Sorry, P is a function of N. So here, my P value are my X's, my prices are my X's, and my number of shirts sold, no, my prices are my Y's, and my number of shirts sold are my X's, because it's, again, always Y is a function of X. So here, price is a function of shirts sold, which means number of shirts sold is X and price is Y. So I have 2 points. I need to find the equation of a line. Moral of the story. I'm going to do the exact same thing I did before. I did this exact same thing with this table, remember? And I'm going to find the equation of the line. So this is x1, y1, x2, y2. My slope is going to be 40 minus 28 over 6,000 minus 8,000. 40 minus 28 is 12 over negative 2,000. That is negative 0.006. So remember that we have y equals mx plus b, and I just found m. So y equals negative 0.006x plus b. I'm going to take this x and this y and plug in. So 40 equals negative 0.006 times 6,000 plus b. This way we can solve for my y-intercept. So negative 0.006 times 6,000 is negative 36. Add the 36 to both sides. And b equals 76. So then in the function notation that they want, you would say p of n equals negative 0.006 n plus 76. That was 2.1. Now let's look at 2.2. Thank you, Katie, for pointing out that I was doing them in a weird order. Okay, so when we are graphing this, you're going to graph it basically given the information, keeping in mind that this number back here is your y-intercept. So I'm going to go to 2 on the y and put a dot. The number in front of your variable is your slope. A slope of negative 4/3 means from this dot, I go down 4, 1, 2, 3, 4, and to the right 3, 1, 2, 3. 1, 2, 3, 4, 1, 2, 3. Now, I could also go up 4, But then in order to compensate for that negative, I would have to go back 3. And then draw your line. Okay. So for the end behavior of this, as x goes towards positive infinity, that means as the function goes this way, is y going down or is it going up? That's what you're asking yourself. And in this case, y is going down, so that's negative infinity. And then we're going to ask ourselves, okay, as x goes this way, y goes up, so y goes toward positive infinity. Now, I know I mentioned this the last time that we talked about end behavior, but another quick reminder that those 6 boxes will always be the exact same as that. If your linear function is decreasing, it's negative infinity, positive infinity. If your linear function is increasing, then it's positive infinity, negative infinity. But, I mean, if this were a test and you only had 1 submission, you could at least be confident that you would get 6 out of 8 of those things right. As long as you remember that. Okay? So, yeah.
In this case, would we use X and Y or would we be using the
Oh yeah, you'd use whatever stupid
letters?
they gave you.
Okay, I just want to make sure. That's fine.
Dumb. Sorry. I hate that Moore does that. I wish everything should just be X and Y. Okay, so a reminder that if all you have is Y, remember f of x is the same as Y, then you have a horizontal line. So this is a horizontal line at y equals 6. If all you have is x or something other than function notation, then you have a vertical line. This is a vertical line at x equals 4. So y equals is horizontal, x equals is vertical. Or your function notation equals is horizontal, and your variable equals is vertical. Okay. So remember that lines that are parallel means they will never intersect. So in order for the lines to never intersect, they have to be rising and running at the same rate, which means that parallel lines have equal slopes. And perpendicular lines, those lines cross at 90-degree angles. Their slopes are negative reciprocals. So you change the sign and flip it over. So here, if we had a slope that had, we had a line that had a slope of 2, a line parallel would also have a slope of 2. A line perpendicular would have a slope of negative 1/2. Change the sign and flip it for perpendicular, keep it for parallel. Okay. All right. Now for the next one, the x-intercepts are where y equals 0. So to find the x-intercept, I'm going to set y equal to 0 and solve. Subtract the 7. divide by 9. And they want a decimal to 3 places. So -7 divided by 9 is -0.778. Oh, they want it as a 0.2 then, right? -0.778, 0. And then your y-intercept is where x equals 0. So y equals 7 plus 9 times 0. 9 times 0 is 0. Y equals 7. That was a lot more work than I needed to do. Remember, the y-intercept when you're in slope-intercept form is just that number that's hanging out by itself. Okay. Now, for these drop downs, your options here are increasing or decreasing. In this case, H is increasing because your rate of change is positive. Your slope here was 9. And a slope of 9 is positive. With a positive slope or a positive rate of change, your line is going up, which means that your function is increasing. And a function that is increasing means that as x goes to infinity, y goes to infinity. Oh, this should be an h. And as x goes to negative infinity, h also goes to negative infinity. Do they want h or do they want like the full h of x? I don't remember.
Yeah, they want the full h of x.
Dumb.
Yeah.
Dumb. This is one of the reasons why I'm actually like, I don't mind this setup as much as I thought I would. We're live online. Like at first when he told me, I was like, oh, that's gonna suck. But it's actually, I mean, I feel like I've been enjoying it. It's easier than I thought it would be on my end, but I don't like things like this. I feel like that's nitpicking on Moore's part. So, you know, if I was giving you an actual test, I would never give you anything but x and y. Either way, if you accidentally put y, press message my instructor and I'll give you credit. I promise. Okay, so to find the equation of a line, again, we always find the slope first. So this is x1, y1, x2, y2. So -4 minus -4 over 6 minus 17. -4, that's going to be 0. So if you have 0 in the numerator, then that means that you have a horizontal line. If you have 0 in the denominator, then that means you have a vertical line. So remember, a horizontal line is y equals, or in this case, g equals. So we would say g of x equals, and then just see how these are both the same y value? So you would say g of x equals -4. Now, if you had had the same x value, you would have said x equals, and then whatever that x value is. Okay? Or does that say use a? G of a equals, this thing is dumb. It's a piece of paper and I'm mad at it. Dumb paper. So again, 0 in your numerator when you're doing slope means your line is horizontal. A 0 in the denominator when you're doing slope means your line is vertical. Okay. I don't know why I put this next one on here, probably because of redundancy. I figured why not, but here function notation is just 2 points. So here they gave me 2 points. The 2 points are 13, -3, and -7, 13. See it? XY, XY. So x1, y1, x2, y2. So find the slope first. 13 minus -3 over -7 minus 13. That's going to be -20. That's going to be -4/5. In his lecture, does Andy show you point slope? Okay, I guess not. So y equals -4/5 x plus b. So use either point. -3 equals 4/5 times 13 plus b. 4 times 13 divided by 5. Oh, that's a -4/5. -10.4. And then add the 10.4. Uh, 7.4 as a fraction if it wants fractions. Remember, we do math enter. -4/5 x plus 37/5. Or you can do decimals. I think if it doesn't specify, you can put in either. So then up here we would say Q of V equals -4/5 x plus 37. And honestly, on this one, you could do the same thing that I showed you and put this in y equals and then plug in 13 and plug in -7 and make sure you get the right outputs.
That's where you getting the V, because I was looking for the input.
It says right here, use V.
Down at the bottom.
Yeah. Use V for your input variable. Right below.
Both of oh, okay, I see it. It's an R though.
Oh, is it an R? Ah, whatever.
Yes,
You get it.
I get it.
Q of R.
It's hard to see those sometimes.
Yeah, it's partly, it'll be easier for you to see on your screen. It's partly that, like, the way that I put this on the paper, the print came out really small. It's also that this is like the last day that I should be wearing these contacts, so they're like fuzzy. Okay, so then last but not least here, you're given a point. This is the point -2, -19. I don't know why I said 19 in row 12. And a line parallel. So remember that parallel lines have equal slopes. So they gave me the slope. If the slope of this line is 19/10, then the slope of the line I'm trying to find the equation for also has to be 19/10 because they are parallel. If that had said perpendicular, I would have flipped it and negated it. So I would have said -10/19. But since it's parallel, I'm going to use that same slope. So this is my x and this is my y for y equals mx plus b. So y equals -19. M is 19/10. X is -2. So 19/10 times -2 is -3.8. Add the 3.8. -19 plus 3.8. -15/2. or 15.2, excuse me. Math, enter, enter. Negative 76 over 5. So M of C is 19 over 10 C minus 76 over 5. And again, I think that if it doesn't specify it around that you can use decimals, I don't know. Whatever you're comfortable with.